Welcome to Brain Vision.
Boron have nuclear number is 5, atomic number is 5, and the question asks us what is the effective nuclear charge and will be different for the 2s and 2p orbitals electron. So with 5 electron configuration will be 1s2, 2s2 and 2p1. And so you can see that at the outer layer there are two types of electron, s and p, 2s and 2s and 1,2p. And the effective, in general, the effective nuclear charge will be equals the atomic charge minus the number of shielding electron. And in this case, atomic charge is 5 and minus number of shielding electron. In this case, there are 2 in the inner layers, make it the effective nuclear charge is +3. However, that is, we have an assumption that the shielding effect of the interaction between the outer layer electron are the same. So assume interaction between 2s and 2p electron are the same and negligible. In other words, they are equal to 0. In the real world, however, there are interaction between electron in between those outer layers electron. So between electron in 2s and 2p, and so if you look into the geometry of the s orbital, it is a spherical. Meanwhile, a p orbital is actually this 8-shaped orbital, depending on the axis x, y, sorry, this is z, this is x, y. You see me drawing over here, z, x, and this is y. And so because of the shape of these orbitals, the ability of the p orbital to shield an excess electron from the nucleus is actually much weaker than the opposite. So in another word, ability of s orbital, s electron, to shield is larger than that of p electron. And so as a consequence, when we look over here, this equation 1, we can see that the shielding effect of the s orbital onto the p orbital would be higher than the shielding effect of the p orbital onto the s orbital. And as a consequence, the effective nuclear charge of the s orbital should be larger than the effective charge of the p electron. It is again because of this ability of shielding of the s is higher than p.